Going over the quadratic questions that y'all had for yesterday's homework. So question number 1, you should have selected A. Question 3 was B. Question 6 was x equals 8. Question 13, x is equal to 11. Question 15, x is equal to negative 2. Question 18, the distance is 23. Question 30, it is a multiple choice one, and you should have selected the 2 middle coordinates. Question 35 was D, and question 45 was C. So again, if there's any questions that you would like to see done, just shoot me an email or a Canvas message and I'll go ahead and do a video that goes over those problems. We're going to go ahead and take a look at our notes for today. And we're actually going to be covering 2 sections. You can see that we have exponents and geometry allotted for today. So we're going to go and work on our notes. So let's start with our exponent notes. We're going to review our exponent properties. And our product and our quotient property is what we're going to begin with. When we have our product, which is multiplication, we need to remember that we are going to add our exponents. So if I have x to the third times x to the second, I am going to do x3 plus 2 in order to have x to the 5th. All right, similarly, the opposite of multiplication is division, and the opposite of addition is subtraction. All right, and in this one, I'm going to go ahead and do 3 minus 8. We do our numerator exponent minus our denominator exponent. And in this one, we're going to get x to the negative 5th. All right, if we remember to when we covered this, we're actually not allowed to have a negative exponent. So when I have a negative exponent, I shift the portion of the fraction that it's currently in. So I'm going to go ahead and take the reciprocal. So this is going to be 1 over x to the 5th. In our next one, we have power to a power. So I have a double exponent with a single base. So we're going to multiply those exponents. And what I say to you guys is we call it, we're going to distribute that even though it's not really distribution. So this second power is going to everything inside. So 3 squared is 9. X to the third to the second, we're multiplying. So 3 times 2 is getting me x to the 6th. And then my denominator, I have y to the 5th to the second power. So 5 times 2 is y to the 10th. All right, on this side, notice that the denominator is not included in those parentheses. That's our difference between the first and our second problem. So that second power is only going to get distributed to our numerator in this problem. So we have x to the third to the second, so 3 times 2 is going to get me x to the 6th. Remember, on that y, there's an exponent of a 1 that we are too lazy to write. So it's y to the first to the second. So 1 times 2 is 2, so I have y squared. And I can't forget about that y to the third. That is in my denominator. So when I go ahead and subtract that, I'm going to get x to the 6th, y to the negative 1. because 2 minus 3 gives me negative 1. And again, I'm not allowed to have a negative exponent. So I'm going to go ahead and rewrite this as x to the 6. I don't move that from the numerator because that is a positive exponent. I am only going to move my negative exponent to the other half of my fraction. So since it was in the numerator, I'm going to go move it to the denominator. And my final answer is x to the 6 over y. That first power that I wrote there is not necessary. I was just putting it so we could see it. All right, so we've already been touching on this, our negative exponents. All right, and just like I did in this problem here, if we look at our first question, we have x to the negative third and y to the fifth. Again, I'm only going to shift the exponent that is negative. So y to the fifth does not need to move, but x to the negative 3 does. So I'm going to have y to the fifth over x to the third power. And that one's done. All right, our next one, we've got a little bit more going on. So we're going to go ahead and start by distributing our square. And we have that square that is going to go to the y, to the x, and to that constant of negative 8. Remember, negative 8 squared. When I do that, if I use my calculator and I do not put parentheses in the correct place, I'm going to get the wrong answer. But we need to remember that two negatives turn into a positive. So negative 8 times negative 8 is positive 64. All right, I have x to the second. 2 times 2 is x to the fourth. Then I have y to the negative 3 to the 2. So negative 3 times 2 is going to get me negative 6. And that denominator we have not touched, so this is just going to come over. All right, now you do have more than one approach to this. Some students may shift our negatives. Some students are going to go and simplify with subtraction first. And that's the pathway I'm going to go ahead and do. So if I look at it, I have a y in the numerator and the denominator. Negative 6 minus negative 2. Minus a negative turns into a positive. So negative 6 plus 2 is going to go ahead and simplify to give me y to the negative fourth. Just kidding. No, I'm good. All right, y to the negative fourth over negative 5. And again, I cannot stop there because I have a negative exponent, and that's a no-no. So my final move is going to be taking that negative exponent and shifting it from the numerator to the denominator. So my final answer is 64x to the fourth over negative 5y to the fourth. And we're done on that one. Roots are something we have not worked with very much. All right, so I'm going to expose this to you, but I don't want you to really focus on it and freak yourself out too much. We have to understand that the third root of x is the same as x to the negative 1/3. That is going to be something that's going to pop up in Math 2. All right, so specifically, the third root of x is equal to x to the 1/3, or in general, the n root of x to the m is equal to x to the m over n. All right, so what we're going to take a quick look at is simplifying a radical. And there's more than one way to do this. We can use perfect squares. I'm going to show you the birthday cake method just because we seem to do a bit better with this, but I can show you both. So simplifying radicals is something that if we don't have a perfect square, all right, and you're told to give an exact answer, we can simplify our radical because we know we can't go and put it in decimal form because that would be a rounded answer. So simplifying the radical, we're going to use our birthday cake method, and we divide by prime numbers only. Prime are numbers that are divisible by 1 and itself only. So examples of prime are 2, 3, 5, 7, 11, 13, and so on. If you take a look at each of these numbers, the only factors of them are 1 and 2, 1 and 3, 1 and 5. They have no other factors for it. So let's take a look at our example. We have the fourth root of 48, a to the 8th, b to the 4th, c. This number right here, that fourth root, this is what we are going to call our index. All right. Now what I'm going to do is take this number, and we call that our base, and we're going to put that at the base, the bottom of our birthday cake. All right, so I'm just getting it all in. Our birthday cakes may look different when we go through this, but our final answers will be the same. So if I take a look at 48, there are more than one number that goes into it. I'm going to go ahead and say, all right, well, 48 is divisible by 3. All right, I'm going to put that 3 on the outside of the birthday cake. And when I go and do 48 divided by 3, I'm going to get myself 16. And this is the next tier of my birthday cake. So then I go ahead and I think, all right, well, what goes into 16? What prime number divides into 16? And we know it ends in an even number, which means it's going to be divisible by 2. All right, and 16 divided by 2 is going to get me 8. All right, again, I've got myself an even number, so I know it's going to be divisible by 2 once again. 8 divided by 2 is 4. Oh, I've switched up my colors. No. All right, and 4 divided by 2 gets me 2. All right, and once again, we know 2 goes into 2, which gets me to 1. This is why I call it the birthday cake method. The purpose is to get your birthday candle on top. So you have to get yourself to a 1 on the top of your cake. All right, and if you're looking at it going, what the heck does this mean? All right, when I'm simplifying a radical, the index is deciding how many matching numbers I'm looking for. So since my index here is 4, I am looking for 4 matching numbers. And if we take a look at this, we have 1, 2, 3, 4. We have 4 2s. Since I have 4 2s, that is going to be a whole number that is going to go on the outside of my radical symbol. The leftover numbers that do not have 4 matching pairs will go underneath my radical. I'm putting a space right now, and I'm going to talk about that in a moment. Remember, this is the fourth root. All right, so if we look at this, we've dealt with our numbers. We've dealt with that constant of 48 up front, but we have not dealt with our variables. And when we discussed radicals before, we divided. All right, so when we were taking the roots of radicals, we went and divided by 2. All right, and that was a square root. So here we're taking the fourth root. So what we're going to do is divide our exponent by the radical. So I have a to the 8th. I'm going to divide by 4. 8 divided by 4 is going to get me a to the 2nd power. All right, well, b to the 4th. So 4 divided by 4 is going to get me b, because that is an exponent of 1. Again, I don't have to write that 1. When I'm taking even roots, I have to understand I have a positive and a negative answer. And then I cannot forget about that c. All right, again, that c has an exponent of 1. And 1 is not divisible by 4. So just like that 3, all right, that c is going to be a leftover that has to go underneath my radical symbol. And that right there is our simplified radical form. All right, so exponential shifts. Our exponential that we worked with was y equals a times b to the x power. And let's review what the parts of that mean. That a is my starting number. Okay, my b is going to be my rate, which we also have referred to as our multiplier. And my x is going to be my time. All right, one of the big things we looked at for this was exponential growth and decay. And we're just going to talk about that for a moment. When we have exponential growth, we did a lot of interest problems. And when we talked about that rate, what we said is that is 1 plus, or 100, depends on how you want to word it. I'm going to have 100% plus that additional percent. And again, if we talked about it and I said, all right, if you were getting 3% interest at the bank, you want to keep 100% of that money that you've invested and make an additional 3%. So we were talking about this and we were saying we have 100% plus the given percent that you're using. Realize we never are going to put percents into our equation, so that is something that you will have to convert to decimal form. Decay is when I'm decreasing, I'm getting smaller. And in this case, we're going to have 100% minus the given percent. So let's take a look at this one. If you start with 10 bacteria, look, it told me start. This is going to be my A value. All right, and they grow. That's important because it's telling me I have exponential growth by 5%. All right, so there we go. They've given me my percentage. We want to write ourselves an equation. So again, we have to understand that we have 100% of the bacteria we start with and an additional 5%. All right, we're going to be using this formula up here. So we have y equals A. We said A is our starting value. We started with 10 cells or pieces of bacteria. Our multiplier in this, okay, we said it's going to be 100% plus 5%, which is 105%. But we cannot use a percentage in our formula, so we take and shift that decimal point 2 to the left, so it's 1.05, and we're going to maintain that exponent of an x because we were not given our timeline. We could put anything in there. We could say, all right, well, how much are we going to have in an hour, 10 hours, 24 hours, and so on. The next one is a decay problem. So here we've got cells dying. In this one, we're going to have 100% minus 5%. And that is going to be 95%. That means 95% of the cells are surviving. All right, so anything below 100 is going to be, or 100% is going to be a decay. All right, we're starting with 10 cells of bacteria. We're not using percents. We have to write that as a decimal, so it's 0.95 to the x power. All right, let's go ahead and take a look at our examples. Our first one, a car appreciates. Here's going to be a little bit of vocabulary. We need to understand that appreciates, okay, is increased, so this is a growth problem, at 2.5%. The start value in 2010 was $20,000. All right, so this right here is telling me my starting value, which we're going to call A. And it's asking me what is the value of the car in 2015. So we know that we have Y equals A is our starting value, so $20,000. This is a growth problem. So we're going to have 100% plus 2.5%. Okay, and that's going to get you 102.5%. And we know we have to write this as a decimal. So we go 1, 2 to the left, giving me a rate, we're going to put our percentage rate as 1.025. Now let's take a second and talk about what I should put as my time. And we discussed this when we were dealing with our statistics unit. Now I told you that they're going to put this somewhere on your EOC. Your calculator and these equations do not understand calendar years. So I have students that go, oh, what's the value of the car in 2015? I'm going to put 2015 in for my time variable, my x. But the issue with that is that the equation then thinks you have owned that car for 2015 years. Okay, it doesn't understand that's a calendar. So what we need to look at is, what is the difference? How long have I owned this car? And if we're looking at 2015 and we purchased it in 2010, that means 5 years have gone by. All right, we would go ahead and use our calculator. We would do 2,000 times 1.025 to the 5th power. Make sure we pay attention to our order of operations. And what we would find is that after 5 years, our vehicle is now worth $22,628.16. All right, pulling from what we just did in that last problem and in writing our percent, our rate, says by what percent is the car appreciating or depreciating by each year? Right away, if you look at this, this is less than 1. All right, and I said if it's under 100%, which converts to 1, then I am going to have a decay problem. If it is greater than 1, I am going to have a growth problem. Identifying your rate in growth is quite easy. All right, it's just how much more than 1 do I have? And in this case, it's 0.07, which is 7%. All right, in decay, I'm looking at how much smaller is it from 1. All right, and if I go ahead and I do 1 minus 0.87, I'm going to get 0.13, which means this is a 13% decay. All right, simplifying our radicals with this one, again, we have to remember we discussed before an index. In this is a square root. This is something we've been doing before. We haven't dealt that much with other types of roots, but a square root we should be pretty comfortable with. If I take the square root of x to the 12th, when we were dealing with it, we divided it by 2. We were doing this in our square root section with our quadratics. So if I take 12 and divide it by 2, I am going to get x to the 6. If I take 8 and divide it by 2, I get y to the 4th. And that one's all done. All right. When I take a look at this one, I'm doing the same thing, but I have a different index. And additionally, I also have a constant up front here. So if I take the third root of 8, I'm figuring out what number times itself will give you 8. And in that case, it is going to be 2. Right? You can also use your calculators to take any root, and you can use Desmos to find any root. Right? If I take x to the 6 and divide it by 3, so 6 divided by 3 is going to get me x squared. Y has a 1, and we know 1's not divisible by 3. So we are going to have to keep that y underneath my roots, okay? And then z to the 9th, 9 divided by 3 is 3. All right, so those exponents and those roots all start to get a little jumbled, so just be careful with that. Simplifying. Look at this. This is a perfect square problem. The square root of 14 is the square root of 16 is 4. The square root of x squared, we divide our exponent by 2, so it's x. The square root of 9 is 3, and we do have to remember that square roots have both a positive and a negative answer. All right, square root of 300. We could approach this with the birthday cake method. The other method is figuring out what square root evenly divides into this number. So if we were to think about our perfect squares and you're trying to figure out, all right, what's my biggest perfect square that will divide into 300? We would realize that 100 times 3 will get me 300, and 100 is a perfect square. So I'm going to write the rest because we haven't dealt with any of it and I don't want to lose it. The square root of 100 is 10. All right, so the square root of 100 is 10. Remember, a square root, I'm looking for a number times itself that will get me back to my base. The square root of 3 is not a perfect square. So that is going to have to stay underneath my root symbol. A to the 4th, we divide it by 2, all right, and I'm going to get a squared. B to the 5th, all right, what I have to understand is that 2 2's go into b to the 5th. All right, so I have b squared and b squared, and that's going to get me to b to the 4th. All right, but I still have a leftover 1. So I'm going to have b squared and my leftover b. And this is a root, a square root, so I have to have a positive negative symbol. All right, here's our simplifying exponent problems. With this one, you need to start by addressing your product, all right, your power to a power rule over here. This third exponent, all right, that cube root needs to go ahead and, not our cube root, pardon me, our cube needs to go ahead and be put to every term inside our parentheses. So it's going to the z, the y, the x, and that 2 up front. 2 to the 3rd power. 2 times 2 is 4, and 4 times 2 is 8. X to the 2nd to the 3rd. All right, that means 2 times 3 is x to the 6. All right, 3 times 3 is y to the 9th. And z to the 1 to the 3rd is z to the 3rd. I haven't dealt with that second parentheses, so we need to bring that down and deal with that now. We do not want to forget about our constants up front. That's probably the most common mistake I see here. So now I have 8 times negative 8, and that's going to get me negative 64. All right, and here I have x to the 6 times x. There's a 1 here. When they have their own bases and their own exponents, we add them up. So 6 plus 1 gets me x to the 7th. Y to the 9th times y to the 5th. 9 plus 5 gets me y to the 14th. Z to the 3rd and z to the 4th gets me z to the 7th. And we are all done. Sometimes students start to get distracted and they go, oh, well, I have a negative there. I'm not allowed to have a negative. You can have a negative constant. You cannot have a negative exponent. So make sure we understand those differences. All right. So B, I have two fractions. All right, and I'm going to go ahead and simplify them. My personal choice, and again, you have more than one way to approach this. Some students will multiply across and deal with their numerator, and then their denominator, and then simplify. Some students decide to simplify within each fraction, and then continue. Lots of different ways of doing exponents. What I'm going to choose to do is simplify each of my fractions. So if I look at 2 over 8, I know that is going to simplify to 1/4. All right, and remember when I am dividing, I'm subtracting exponents. So I have x to the 1 over x to the negative 3. 1 minus negative 3 becomes 1 plus 3. So I have x to the 4th. And then I have negative 4 minus negative 9, again turning into a positive. So I have y to the 5th. This fraction is now simplified because I only have one variable one time. All right, no repeats. Let's hop over to the other side. 9 and 4 don't simplify, so I can just write them. I've got x to the 2nd over x, so 2 minus 1 leaves me with just x. I've got y to the 1st power minus negative 5. Again, that minus negative becomes a positive, so I have y to the 6th. And now I get to go ahead and take a look at this. Multiply across the top. 1 times 9 is 9. X to the 4th times x. Again, they've got their own bases. And we're going to go ahead and add them up. So 4 plus 1 is 5. All right, y to the 5th times y to the 6th. We're going to add them up and get y to the 11th. Our denominator, all right, so I've got 4 times 4 is going to get me 16. And then we want to go ahead and take a look at our constants and see if we are able to simplify them. When we take a look at 9 and 16, and we realize that we're done. All right. Question 5. I believe there's one of these on the practice EOC, and this is definitely one that really gets to students. So it says, what is the first? That's important that we understand it's first. What is the first value of x that will make f of x greater than g of x? So let's go ahead and write that. We've got 1/2 times 2 to the x power is greater than or equal to 5x plus 2. So we need to figure out what value of x will make this true. First thing I want you to understand is we don't know how to solve this, okay? We're going to need to go and do guess and check. We're going to choose a number. We're not going crazy. We're not choosing fractions. We're not choosing any ugliness. We're just going to choose a number in the beginning and try it. So I'm going to go ahead and try 5. All right, so I'm going to try 5. And unfortunately, you're going to do guess and check with this. So I try 5. I have 1/2 times 2 to the 5th power is greater than or equal to 5 times 5 plus 2. All right, and we would go ahead and use our calculator and go and solve this one. Let me actually take a quick peek at the practice test for this one. All right, so on your practice test, this is actually question number 5, and this is the non-calculator portion. Just keep that in mind, okay? So that's going to make it a bit more challenging because we definitely could say, let's go and use some Desmo, something else, but this is not a calculator. So we would go ahead to the 5th power, take half of it, we're going to get 16. 5 times 5 is 25, plus 2 is 27. So we take a look at our inequality, and we want to see if it's true. And it says 16 is greater than or equal to 27. But we know that's not true. 16 is not bigger than 27. So we can go ahead and try 6. All right, so I have half times 2 to the 6th power is greater than or equal to 5 times 6 plus 2. The 2 to the 6th power really is not that bad, guys. All right, so if you're going, how am I supposed to do that with a calculator? 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. We know 2 times 2 is 4. All right, and we go ahead and say, oh, well, 4 times 4 is 16. All right, and then we would go ahead and pull that last 4 in, and we go, all right, 16 times 4 is 64. All right, and half of 64 is 32. All right, and we know 5 times 6 is 30, and 30 plus 2 is 32. And this is our answer. So that's going to be a guess and check problem. All right, so that was our exponent section. I told you we were going to knock out 2 today, so we're going to hop over to geometry. All right, our top portion, you guys can go ahead and take a look at that on your own. That's reviewing our midpoint formula, which we know is the middle or the average of our points. So we add them up and divide by 2. Let's review our formulas. We know that the area of a rectangle, we have been doing that, is A equals length times width. All right, pretty easy for that. Our square is a special type of rectangle. It's a rectangle with 4 equal sides. So you can actually go ahead and use length times width for this one. Additionally, since our sides are equal, we can also say A equals S squared. A triangle is half of a rectangle. So we can go and say area equals half base times height, because we're taking half of that rectangle. All right, a parallelogram is kind of like a rectangle that got pushed over a little bit. So for this one, we have area equals base times height. It's pretty similar to your rectangle, but you have to understand that your height needs to be perpendicular to the base. So you won't be using the slanted side. You're going to have to find the height in the middle. That holds true for trapezoid as well. All right, our trapezoid is probably, in my opinion, one of the harder equations. So again, I'm going to have my height that is perpendicular to my bases. And I have area equals height times base 1 plus base 2 divided by 2. All right, base 1 and base 2, since you got a flat top and a flat bottom. I don't want you to worry about kite. And then circle, all right, we're going to go ahead and have area is equal to pi r squared. All right, r is talking about radius. When we talk about it in a minute, d is going to be our diameter. For our formulas for perimeter, I'm not even going to worry about them, okay? I want you to understand perimeter, we just add up our sides. We do not need to try to remember any formulas with that. So add up all the sides. The only one that is slightly different, and that's also because it's not called perimeter, is going to be circumference of a circle. And circumference is equal to pi times our diameter, or the circumference is 2 pi r. All right, so the first example, if the perimeter of a triangle is 3x squared plus 5x minus 4, the sum of two sides of the triangle is 2x squared plus 3x plus 6. Find the third side of the triangle. Okay, so what we know is two of the sides already add up. And we actually did a problem like this on our test. We probably had it on two separate tests, actually. But instead of me already adding them up on the last test, I gave you the two sides, and you had one extra step. So in this problem, we'll go ahead and say, well, this one here and this one here add up to be 2x squared plus 3x plus 6. And I need to figure out what my missing side is. So I don't know this one. This is your total. This is your perimeter. That is all three sides added up. So we're going to go ahead and take the total and subtract out the parts. And that's going to leave me with the remainder, which is going to be our missing side. So again, when we did adding and subtracting in our quadratic section, we deal with our coefficients up front only. 3 minus 2 is 1, so I have 1x squared. 5 minus 3 is going to be 2x, and negative 4 minus 6 is negative 10. And that is my answer. So definitely looked a bit more overwhelming because of all of your exponents in the standard form, but it really was not that bad. All right, so we've got our distance formula. Remember when we talked distance formula, I told you that it is a bit more complicated to remember. And if you've remembered it and you like it, fantastic. If not, we learned how to use Pythagorean theorem in its place. Remember, Pythagorean's a squared plus b squared equals c squared. All right, so if I say find the perimeter of the triangle with the given vertices negative 2, 3, 2, 1, and 5, negative 2, we're going to use the graph paper to do that. So let's go ahead and graph those points. Negative 2, 1, 2, down 3. All right, we've got positive 2, up 1. And we've got positive 5, 1, 2, 3, 4, 5, 1, 2, down 2. So if we look at this, unfortunately, none of them have nice pretty sides on our graph paper. They're all diagonals. So we're going to be using other sides. We're going to make ourselves from right triangles. All right, so I'm going to go ahead and use this grid paper to my advantage. And what I'm going to end up doing in this problem is I am making 3 separate right triangles. My lines are a little crooked, but we're going to count up our sides. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. All right, 1. And we've got 1, well, 4 and 3 is going to give me 7. All right, and what I need is the diagonal of every single one. So I am going to do my Pythagorean theorem 3 times. All right, could you do distance formula? Absolutely, and that is 100% your choice. So I'm going to deal with triangle 1, 2, and 3. So for triangle 1, I'm going to do 4 squared plus 4 squared equals c squared. We know 4 squared is 16. 16 plus 16 is 32. We're going to take the square root of each side, and we know that c is going to be 5.7. So I did my first one. Now I'm going to go ahead and kind of color code it. I'm going to do my next one. So I've got 3 squared plus 3 squared equals c squared. And we know 3 squared is 9, so 9 plus 9 is 18. Again, we have to take the root because I don't want c squared, I want a plain old c. And we've got c is equal to 4.2. All right. My last one, I'm going to go and do 7 squared plus 1 squared equals c squared. 7 squared is 49, and 1 squared is 1, so 49 plus 1 is 50. Take your roots. So c is 7.1. Well, we know the perimeter. We've got to add up these 3 sides of our triangle, and we're going to find that the perimeter is 17. All right, that's why you guys are going to have graph paper, so you can use whatever method works for you. Find the diameter of the given volume of a sphere with a volume of 30 centimeters, where v equals 4/3 pi r to the 3rd power. All right, so what we're going to do is we need to understand that the volume is 30, so this needs to go in for the v. That removes one of my variables. So I'm going to have 30 equals 4/3 pi r to the 3rd. We don't like fractions, so we've been talking about how to get rid of them. So we're going to multiply this entire thing by the denominator, which is 3. And when I do that, I'm going to get 90 equals 4 pi r to the 3rd. Okay, so what we need to go ahead and do is divide each side by 4 pi. You could divide each side by 4, then divide each side by pi. I'm just going to choose to do it together. So I'm going to divide each side by 4 pi. All right, and that's totally a calculator thing, guys. I'm not expecting you, and they're not going to expect you to divide by pi without a calculator. All right, and what that leaves me with r to the 3rd power is equal to 7.16. And again, I just want to know what my r is, so I'm going to take the 3rd root, or the cubic root, of each side in order to find that r is 1.93. Now, I've told you to be very careful of reading directions because we're going to get distracted. It's saying find the diameter. Radius is half the diameter, so we need to multiply this by 2 in order for me to get that the diameter is 3.86 centimeters. All right, let's take a look at our last question. One leg of a right triangle is 2 more than the smallest leg. The hypotenuse is 4 more than the smallest leg. Find the sides of the right triangle. All right, so let's go ahead and start with a diagram. All right, so one leg of a right triangle is 2 more than the smallest leg, and the hypotenuse is 4 more than the smallest leg. They keep talking about this smallest leg, but I don't know it. So I'm going to go call this small leg x. All right, and it tells me the other leg is 2 more than. We know more than is plus. Okay, so I'm going to have x plus 2. And then the last side, my hypotenuse, is 4 more than the smallest side. So it's going to be x plus 4. All right, it tells me to go find the sides of the right triangle. It told me it was a right triangle for a reason. So what I need to go ahead and do is Pythagorean theorem. I have x squared plus x plus 2 squared equals x plus 4 squared. All right, and when we take a look at it, remember, I don't distribute, I write it twice. All right, so I'm going to have, for this one, this is going to be x plus 2 times x plus 2. And this one's x plus 4 times x plus 4. So we're going to have to simplify it. We're going to need to either use box method, double distribution, FOIL, whatever clicks in your head. When we do that, we get x squared, hasn't done anything. All right, x plus 2 times x plus 2 is going to get me x squared plus 4x plus 4. Over here, I'm going to end up with x squared plus 8x plus 16. All right, well, let's go ahead and simplify it. We can't do anything when we got stuff on each side. We've talked about that before. So I'm going to bring everything over. When we cross that equal sign, we use inverse operations. And I am lining it up with its like term. These all cancel out. Well, if we take note on this side, it's also going to cancel out my second x squared, which is wonderful. I have x squared. 4 minus 8 is negative 4x. And 4 minus 16 is negative 12. All right, so at this point, we're going to factor it. What two numbers multiply to give me negative 12 and add up to give me negative 4? All right, I'm running out of room. We're going to pop up here because I ran out of room. And that's going to be x plus 2 times x minus 6. Again, we can absolutely do a factor tree if we don't remember them. All right, so you think about 12, you got 1 and 12, you got 2 and 6, you got 3 and 4, and you have to figure out which one is going to be 4 units apart. And we take our parts and we set equal to 0. So I'm going to do x plus 2 equals 0, which means x is negative 2. And here x is 6. Just like before, we're talking about side lengths, y'all. There are no rulers out there that have negative numbers. So my answer is going to be x is equal to 6. But again, it said find the sides. So if this side is 6, 6 plus 4 is 10, and 6 plus 2 is 8. So my sides are 6, 8, and 10. You guys have practice problems. They are listed as 2 separate homework assignments. One is exponentials, one is geometry. They are both short. All right, so make sure you go and get those done.